Jack-up, self-elevating. General description. General description. Primary operational role is to provide a stable platform in terms of wave-induced motions as well as static position keeping in order to conduct an offshore mission activity. Jack-up vessels may be monohull ship-shaped or barge-shaped vessels. 3 or more retractable legs lift the hull above the influence of wave forces and support the weight of the vessel. The operational elevation depends upon the requirements of the mission activity. Jack-up vessels utilize DP for approach and positioning prior to lowering and pinning of the legs. Jack-up vessels are also called self-elevating vessels. Their mission activities include wind farm installation, drilling of oil and gas wells, well maintenance, offshore construction and decommissioning, accommodation. Touchdown is the moment that the first leg makes contact with the seabed and represents the commencement of transfer of position control from the DP system to the legs. Liftoff is the moment the last leg is retracted from the seabed and represents the completion of transfer of position control from legs to the DP system. A gangway may be fitted to facilitate personnel transfers. Large capacity cranes are frequently fitted to support the mission activity. Other industrial mission equipment varies according to the vessel activity. DP operations are frequently conducted in close proximity to other vessels or offshore structures prior to the lowering of the legs. High accuracy position keeping is required. The consequences of loss of vessel position may include injuries to personnel, damage to the vessel and/or adjacent offshore installations, as well as environmental pollution. Overstress of the leg structure is a significant risk during the transitions between DP and leg support if the DP system does not maintain position in relation to the seabed. Reference systems and sensors. Reference systems and sensors. At least 3 independent position reference systems employing at least 2 different measurement principles should be used during touchdown and liftoff, and when in close proximity to surface or seabed structures. Reference systems should minimize the risk of degradation during touchdown, changes in draft and changes in deployment depth of legs. These risks include attenuation of acoustic systems reception, variation in relative line of sight measurements as hull elevation varies and protruding legs interfering with satellite systems. Power for the position references should be supplied from different redundancy groups to prevent the WCF resulting in the loss of all position references. When maneuvering clear of other vessels or structures following liftoff, then a minimum of 2 position reference systems should be in use, with a third immediately available. At least 3 independent heading reference sensors for the DP system should be provided due to the critical nature of heading control. At least 3 independent wind sensors should be provided. These should be installed in different locations to allow for local disruption of wind flow caused by leg position. Where wind sensors are mounted at different heights, then information at the DP control station should be corrected to a common height. Additional sensors may be required for specialist jack-up DP modes to address the problems outlined in Section 812-2.3. See current vector sensors to facilitate thruster compensation for the prevailing current following liftoff. Leg position sensors to facilitate automatic modification of wind and hydrodynamic profile in the DP control system. Leg touchdown sensors to facilitate an automatic freeze of DP model integral for environment compensation and avoid overstressing the legs. Operational consideration and planning specific mission. Operational consideration and planning specific mission. The following should be considered when planning DP operations. Jacking operations may be subject to strict wind, wave, and sea current limits. Wind forces may be high due to the size and shape of the vessel structure and may vary significantly depending on the position of legs and cranes. The legs may be overstressed following touchdown if thruster forces are too high. Transit speed will be limited if legs protrude below the vessel hull in transit. Drag due to water flow may overstress the leg structure. Some types of position reference system may be degraded during specific phases of the jacking operation. This should be risk assessed prior to starting elevation. An emergency vessel escape route should always be planned. The joystick may be used following liftoff if position keeping is unstable. Significant changes in vessel stability occur due to the change in position of the center of gravity of the legs during the jacking process. Seabed stability and topography should be assessed prior to any project. General feasibility studies, including checks for punch-through resistance and fatigue, may be required. The master and each DPO should be aware of the hazards associated with touchdown and liftoff, and the appropriate emergency responses following failures. The leg jacking control operator should have instruction in the basic operation of the DP system and the vessel's capabilities so as to understand the potential vessel responses during periods of touchdown and liftoff. Operational planning. Operational planning. Where appropriate, the following should be documented. Risk assessment of the loss of vessel position at all stages of the operation and for all associated activities. All realistic failures should be analyzed by a project-specific risk assessment and project procedures developed as necessary. Configuration for the CAM or for the TAM with specification as to which modes are required for each phase of the operation. A SOG to define the operational, environmental, and equipment performance limits that apply during the jacking operation and give guidance on required actions in the event of these limits being exceeded.